this? Okay, so what we looked at last week was the idea of objects. Now, I'm going to quickly skip through these since we've looked at these slides already, but there's some key elements we take away here. A class is going to be our blueprint. It's going to be the shape that we want our data structure to take. An object for us is a way of making what's called a data structure, a custom data structure. We've been using the built-in data structures in Java for the last semester and a half, and now what we're looking at is how can we make some data structures that are our own. So and when I say a data structure, what I'm referring to is having the data that I want held as a single unit, as a single object. So for example, if I were to go back and have a look at the previous example there with the date object, now this isn't a custom one, it's built into Java for us. But I can see I've got multiple pieces of different information there. I've got a string representing the day of the week. I've got a string representing the month of the year. I've got a number, an integer representing the year. I've got an integer representing the hours, an integer representing the minutes. I have a string representing AM or PM. So there's lots of different pieces of information that I can get out of that. And they're all disparate. They're not all one data type. So I couldn't achieve this by using something like an array because we'd be locked to a single data type. I suppose if I really wanted to, I could create a string that has all of this information in one long data stream. But then I would need some way of chopping it up to get the specific bit that I want. So an object is just a nice way around that. So our class is our blueprint. What shape do we want our data structure to take? An object is the actual instantiation. So we go to use it. So when you would go int x, you're initializing, you're instantiating that variable x, which is of type integer. When we would go date d is equal to new date, or random or is equal to new random. What we're doing there is we're saying, not only do I want to create a variable, but I want to do all of the setup bits that need to be done because this is an object. It's a non-primitive data type for us. Inside our object, we're going to have for us, we're going to have two elements of work. The first one is going to be our instant fields or our variables. And our variables are always going to be private inside our object. And the reason why they're private is we want to restrict access except through approved pathways and approved doors. Okay, so this is a room, we've got doors in it, and we've got windows. There are multiple ways of getting in and out of this room, but there are only two of them which are approved. Door at the front and door at the back. So it is possible to get out the window, it is possible to get that window there. It's not recommended. One way of making it private, if you look out in the windows on this side, as you can see there's bars in the windows in this side. So that's a way of restricting our access, not so much on that side, but there is over here. So we want to make sure that when we create our variables, that they are restricted access. We mark them as private. When we mark them as private, it means that only inside the class that I have can I access any of that information. We then can also have methods. And our methods, for the most part, for the way we'll deal with them in first year and the way we'll deal with them in second year, for the most part, they're all going to be public. And that's our way of getting information in and out of that object in whatever format that will be. And again, I'm going to implement this in a moment, but if we imagine this class here, it's called student information, we are going to start off with three private variables, name, ID, number, and address. So to me, the logical way of doing that is it's a string, it's an integer, it's a string. And then we're going to have two public methods. The first public method is something called a constructor. A constructor is used when we are constructing that object, when we're building it up, our first time of setting it up. So when we've done scanner KB is equal to new scanner system.in, or random or is equal to new random. That's calling the constructor. It's sending in whatever information we need to get that object up and running. And once we've done that, we can use it. So we can call or.nextInt or kb.nextCar or next boolean. And we can pull in information that way. So we're going to create a student information method, which will be our constructor. So whenever we create a student information object, it can go to run the code inside there. And that can be as simple as set all the values to 0 or to null or to empty string, to as complicated as take in multiple pieces of information. You can see I've got some ellipses up here. So it's possible that we take in multiple pieces of information, parse that information through whatever validation I have to make sure that the email addresses are actually email addresses, that someone has put in numbers for their phone number and they've put in a date in the order and the format that we want it in and store it in. And then the second method is much, much simpler for us. It's just print information. So if I were to hop out of this and go and build that, you can't see that. That's not fair to read. Okay, so for this one here, we'll just call it student info. Let me resave this. CS. There was. Okay, so inside here, I'm going to create my variable. So I'm going to have private string name, private int ID number, and private string address. Okay, and you can see from here, I haven't set any starting values. All I've said is create these variables, and they're going to be of this data type, and they're all going to be private. To set up those variables, what I'm going to do is I'm going to have here a method called student information. And I could set up name is equal to John Doe. Spell it. Good Lord. ID number is equal to 1, 2, 3, 4, 5, 6, 7, and address is equal to GCD. Keep it simple there. Okay, so what would happen now is that I have my variables created here, and then when I call student information, it sends in all of the appropriate value for me. And that's absolutely fine, I can do that. It's a little bit simplistic because it means that if I create 200 of these objects, that what's going to happen here is that they are all going to have the same values inside it. And since they're private, and so far, this is all the code I've written here, we don't have a way of changing that. So a better way of writing my constructor, rather than writing it like this, is to write it. That should be public. A better way of writing it is to have it so that rather than saying specifically there are those values there, we're going to take in some values. So we'll take in string n, and we'll take in int ID, and we'll take in string a for address. And now, no matter what the values are sent in here, well, then we'll say, rather than saying John Doe, it's whatever they've entered in for n. Rather than saying 1, 2, 3, 4, 5, 6, 7, it's whatever they entered in for ID. And rather than saying whatever or GCD is their address, it's whatever they entered as A. And now it means that I can have 200 different student information objects created, and it will allow me to have different data in all of them. And that's much more useful to me, because if you think about why we'd want to use this, if I have something like student information, I'm holding names and ID numbers and addresses, that's the student record system. So it makes absolute sense to me that I would want to hold information on all of the students. So we've got 5 or 6 in this class, 7 in this class. We have 200, let's say, in BSc 1. We have 500 in the undergrad of computer science. We have 9,000 across the Dublin campus. We have 11,000 across all of the campuses. Okay, so we can scale up, and this can keep growing. And we can keep this structure for the most part. We're able to say, well, look, all students are going to have a name, they're all going to have an ID number, they're all going to have an address. And when the student registers, we can take in their name and their ID number and their address, and we can add it in that way. The other thing which they talked about there was having a print information. So this this would be public void print info. And for this, we don't take any inputs. We don't return anything back from it. And what we have is we print their name, their ID number, and their address. Okay, so it's a very simple method. This prints it all out. So based on what was asked, that is very hard to read. Based on what was asked in that slide, that is the code for that. I have 3 private variables of sensible data types. I have a constructor, which is going to take in the values I need to set it up, and I have a print information, which prints it out. If I wanted to run this piece of code, you'll note that there's no public static void method in there. Traditionally, we create an object. It is a Java file separate to our program that we're actually running. Remember that we want to use this as a custom variable, a custom data structure. It holds the information we want and specifically what we want for this problem. But it's not the actual program itself. It's a storage definition. So what we need to do here is we need to create our test class. So we create a new file here. We call this class test. And then here we have public static void name. String. ARDS. Okay. Okay, and you can see here we've saved it as our Java file. So we could say student information S1 is equal to new. Student information where we send in a string. So let's send in Owen. We're going to send in an ID number. So let's send in 1, 2, 3, 4, 5, 6, 7. And let's send in an address, which will send in GCD. Okay, so that's my student there created. And if I wanted to run the other method that's in there, the print information method, the way I would do it is I would have s1.printinfo. And when I run this code, it's just going to print out that content on the screen. So if I run it from here, will this work okay here? Yeah. So we can see our output here being O1, 1, 2, 3, 4, 5, 6, 7, and GCD. Now, that's fine for one example. But if I want to do 2 examples, I could take another one there, another one there, another one there. First one is Owen. The second one is Susan. Who's got a different number. That is going to be John. Different number again. And this can be Becky. Okay. I would also need to change these to S2, S3, and S4. And so what I could have here is I could print out S1 first, then S3, then I could print out S4, and then I could print out S2. And that's absolutely fine. I've created 4 students. I've given them some unique information. So they're all living on campus, but they're all different names. They all have different student numbers. And I don't need to print them out in any specific order. Because remember, there's variables. So I'm just saying, oh, give me the information from that variable type. So if I run that now, the output will be much bigger. Never pops up. It's not going to pop up. Excellent. So, terminal. Okay. And then, yes, that's fine. Don't want that. There. Okay. Right. So we can see here we've got Owen. Now we've got John, we've got Becky, and we've got Susan. So the order I created them in, we're not tied to printing them out in the same order. Does that make sense? Again, this is all recap from what we looked at last week. Okay. But if I look at that example there, let's actually look at the student information file itself. That'll make more sense. If I look at that example there, I've got a way of holding information. I've got a way of setting up my information immediately, or when I first create the object. And I've got a way of printing out all the information. But what if I wanted to do more? What if I wanted to change my details? I was living on campus. I had too big a party last Friday. I got kicked off campus. I'm still a student, but I need to update my address. I'm no longer living on campus. I need to update that. We've no way of doing it here. These are private, so there's no way of getting access to them from a file from outside. Our print information, I'll print the information to the screen, but I have no way of editing it there at all. So the last thing that we are going to add into our objects for BSE 1 is the idea of what are called accessor methods, getter and setter methods that will allow you to update the values or retrieve back the values. Okay. Now I know print information is technically retrieving back the values, but it's printing it to the screen. If I call print information because I want to get a number, or I want to find out where someone is living because I want to send them a letter, if you think about an automated system, that's kind of useless, because now I have to open up whatever my system is and manually type in their address. And if I have got 9,000 students and I want to email them all, or I want to post something out to every one of them saying, Dermot Hegarty has won the Euro Millions, and as a result, everybody's outstanding debt is cleared, and whatever course you're currently enrolled on is free until completion. Okay? It's not, he didn't win the Euro Millions, but let's say he did. I'm not going to take 9,000 manual address entries. I want to automate this. So I need a way of returning back, not just printing to the screen, but the actual string that I have for the address, so that I can do like a mail merge and build up something. So what I need to have here is I need to have getters and setters for my object. So I'm going to put them up here. So a getter is going to be exactly as it sounds. It's going to be how I'm going to retrieve that information out. So I'm going to say public. It's going to return back the value. So public string get name. And we don't need to send any information in. Okay. Get the name. You don't need to give it any quantifying inputs for that. What we're going to do here is we're going to say return name. So now I've got a block of code there that will, when I call it, it'll return back the string of whatever is held in there for the name itself. And then what I need as well is I need public int get ID number. Again, that would be something as simple as return ID number. And then public string get address and return address. Okay, so there are getter methods. You can see they're super simple. There's very, very little in them. Everything in this room is falling apart today. No, that's the wrong one. Okay, we'll do that for a moment. So what we have here is that they're very, very simple. It's this get name, and all it does is it gets the name for you and it sends it back to wherever it's been called from. The opposite side of that is where we want to send in a value and go, actually, will you update the existing value there? And so for this one, it would be set name. So here again, they're going to be public methods because we want them to be accessible from outside. So it'll be public. We're not returning anything back, so they can all be void. They're going to be called set whatever. And inside here, we send string s. So we're going to send in a string, and it's going to be put inside here. I was saying s. N makes more sense. And then what I can say here is name is equal to whatever the value is that the user sent in. Now, these are incredibly simple versions of it. There's no reason to have code like this except for the rules of encapsulation, and for first year we can ignore them. We can not worry about what that means. That's all second year. But imagine this was more complicated. Imagine it was, I want to make sure that everybody has at minimum, a first name and a second name. Okay? Or maybe I want to make sure that these surnames are in a specific order. So if you have, maybe I know that whatever way I'm storing this information, hyphens between names won't stick. There have to be spaces. So I could take in the string, that's a string, so it can have any characters we want. But then I can go through it character by character, looking for, let's say, hyphens and replacing them with spaces. So that if someone had a double-barreled name, that it would remove the hyphens to stop my actual storage system crashing, if that was an issue that could be. So I can add in code into this to actually to validate it before it's put in. In the same way, when I'm returning back information, maybe because it would be trickier putting the hyphens back in there. But let's say with the address, I needed to make sure that personal information wasn't given out. So I can have some way of saying, okay, well, actually, do you know what? I'm going to redact. I'll tell you where they live, if it's Dublin or if it's Cork or if it's Paris or wherever it might be, but I'll redact all the other information. So there might be a way of trimming out or of augmenting what you send back. These ones here are really simple. I ask for the variable value, I get it back. I send in a new value, that becomes the variable value. Or do the other ones. Okay, so set name, set ID, int ID, number, ID, set address. Okay, so now that I have this code here, the bits that I had working, so I had my variables, I had my constructor, and I had my print information there, that all still works. So if I went back here and I ran this code, it's not going to give me the output. Terminal, new terminal. You can see that I still get all the information. The information still works. But now my code has been updated, so I have more power, I have more functionality in my code for my student information. So this is again another big advantage of this modularization or compartmentalization of our code. Splitting our code up into methods, as you've done already, or into objects like this, means that I can take an existing program that was working, I can update something here. My code still works, my old code still works, but now I've got extra features that I can pull upon. So what I can do, rather than doing print information, for all of them, maybe I want to do print information for one of them. And then what I want to do here is I want to do sysout for s2.get address. And so I'll get the address back there. Maybe what I want to do then here is I want to, indentation's all off here. Maybe I want to say that s3.set ID is going to be equal to 9999999. And then I want to prove that that's actually working. So s3.get ID. So now I've got a much more interesting piece of code, because I can still use print information here and get the information back. But also I can get back specifically one block of information from one of my objects. And I know I'm printing it out just to prove I've got it back. But this will give me, that will give me the actual string itself. So I could use that to create a mail merge to actually do something. I can set the ID here, so when I get the ID number back, it should be, rather than 7654321, it should be 9999999 as the ID number. So if I save that and run it, get rid of that. You can see here that the first thing it gets back is S1 that information. So I get back Owen 1, 2, 3, 4, 5, 6, 7 and GCD. The next thing it asks for is from S2 to get the address, well, the address for all those GCD, and then it sets the ID for 3, and you can see that it's bringing back here all of the 9s for that. So that's as far as we've got last week. We created an object, which had private variables in it, so we knew we had to have a way of getting in and out of that. We created a constructor, so we could send in our initial starting values. And we had looked at getters and setters for either setting values, updating values, or retrieving the existing information. Okay? And we built a little test program, something similar to that. Does anyone have any questions on that before I move forward? Yes.
Yeah. I was just wondering, if you've got a ton of objects,
yes,
do you just, like, and they're all separate files, are they just all in a folder together? Like, do you have to kind of call them into their main program?
So, yes. If they're in the same folder as wherever the main program is. So, at the moment, both of these files are in my document folder. So, I don't need to import them. I don't need to. So, you know, at the start, sometimes we would have our import java.util. And the reason why we're doing the java.util.asterisk or java. Whatever it might be, is because the Java code that's there, which is another Java file, is not in the same folder as the code I'm writing. For this example here, I have both of those files in the same folder on my machine, so all I need to do is do student information, and it's able to go, oh, I can see that, and I can work on it. It's actually, Java has got better over time. When I first started teaching Java, if I had this arrangement where I had 2 different Java files, I'd have to go in and run Java C on this one first, and then run Java C on this, and then run Java on that to get it to work. Now, I know I'm doing this through a development environment, but even if I went out to the terminal and I don't have my class files, I only have my Java files, if I just compile the runnable program, so in this case here the test, it builds all of the other Java files that might be needed that are in that folder. So if I've got student information and staff information and class information as different classes, it will build all of them if they're required. So it's taken a little bit of the labor out of it. It used to be a case of either you had something like Gradle set up, which you dictate what order do you want things to be built in, or you have to go and do it by hand, whereas now it's built in a little bit. But yes, to answer your question, if it's in the same folder, it automatically, if you declare here student information, it automatically knows, oh, I can see that. Okay. Any other questions? Okay. Okay, so what I'd like to do is I'd like to show you what I've put up on Moodle, although at this point you probably have all got the notification that I put a post up. Hang on a second. We're there. So I want you to build a very simple class. No, we are not doing data structures. There we are. No, there we are. Okay, so this is part 1 of 2 parts we're going to build. So I want you to build a class, you can't read that has a name, a health value, an attack value, and a defense value. I want you to decide on sensible data types for each of the variables and to create a constructor that accepts in all those values. And then you should also create getter and setter methods for each variable. What we're going to do is we're going to build a very, very simple. Have you ever heard of the game Dungeons and Dragons? Have you ever played the game Dungeons and Dragons? Okay. At its core, Dungeons and Dragons is I'm going to roll a dice and get a number. You're going to roll a dice and get a number. Which one of us got a higher number? That's if you boil it down to the most basic element, removing all the narrative stuff out of it, that's what it is. We're going to build a computerized version of that tonight. So to begin with, we need to have our people in our game. Okay, so you're going to create a person class. They're going to have a name, so we know who they are. The health, attack, and defense values are numerical values, so you can create whatever you feel is appropriate for that. Remember, they're all private, and then I need you to do a constructor and getter and setter methods for each of the 4. It's 10 to 7 now. Let's say 10 past 7. We'll have a look at what that should look like. Okay. How are you getting on? I can still hear typing, so give you a couple more minutes. The name of the class isn't particularly important, it's more just does it have all the features we're looking for. Okay, let's have a look at this. So I've created three variables there, four variables there. One's been string, which is the name, and then I have the help, the attack, and the defense. I'm going to start off by creating my constructor, so a public person. And here I'm going to take in a string and then 3 integers. Where we go? And then I'm going to assign them to the responding variables. Okay, so my constructor is very, very simple. I just send in 4 values and I assign them into my my attributes that are inside this class. I also need to set getters and setters for everything. So they're going to look like public void get. name. Should I try to save a bit of space here? Go return name. So get name. Then we're gonna have get health. Get attack. And get defense. Okay, so there's all of my getters. Why does it like that? Because they should have been string. Okay, sorry. So the gets shouldn't have been void because all they're doing is they're actually returning back the values that we have there. And then I need my sets. So they're going to be public. And again, I'm going to do these in one line just to save a bit of space. So it's going to be public, void, set, name, string n, name is equal to n. Okay, so you can kind of see the format that I've done there for that one. And I was going to duplicate that for the other three. Okay. So I have my person object created. So I have my 4 variables up at a screen, but you can see that they're going to be name, health, attack, and defense. Name's going to be a string. The other 3 are going to be integers. I can call a constructor where I send in a name and a health and an attack and a defense. That's fine. And I can also have individual methods for getting back the value inside any one of those attributes, or for setting the value inside any one of those attributes. And that's roughly the shape that your object will take in first year, and kind of in second year as well. Second year, I usually would add in a couple of extra methods into it. So you might have a display or a print information method. You might have a, yes, I suppose it depends what it is, calculate damage if it was this example here. But that's what we have for the moment. Hopefully, that was reasonably similar to what you had created yourselves. And I, like with the previous example, I want to test this. Yep.
Just wondering, for objects, you know, you kind of didn't indent like the return name, like it's not down as it.
Oh, here, that's literally just to save space on this. So I could do it like that. That's absolutely fine. It's just because it's a 2-line or 2-word line of code, and I know it would all fit on the page.
Yeah,
it's just so I can fit everything together from a visual point of view. Yep, no, it's absolutely fine because again, this it's only 1 line of code, and this line is intended. If this was back out here, well then I'd probably have an issue with it. Okay, so as I was saying there, I need to have a. So I need to have here a test, a way of seeing is this going to work. So sequence B. No. Right there. Okay, so here I have got my. You can see I've got my test there. I can create a person. So person P1 is equal to new person, where I send in my name. Send it all in there. Send in health 25. Send in my attack. Let's say it's 10. And my defense, let's say, is 6. Okay. So that will create. That will create an object for me. That will create an instance of this value here. That's great. But since I want to create something that looks a little bit like a Dungeons and Dragons attack, I'm going to need to have more than one person. You can't fight yourself in Dungeons and Dragons. You need to have something else to fight against. So I'm going to create a new version here, or a new person, P2. We'll call this one here Goblin. It's a powerful goblin, so it's health of 45, but it's pretty weak on attack. So let's say 5, and it's pretty weak on defense. Let's say 3. Okay. So now I've created two objects. So I've used my class person and knowing what I have in there to create 2 objects. One's called Owen. It's got a health of 25. It's got an attack of 10 and a defense of 6. And I've got another one called Goblin. It's a health of 45, an attack of 5, and a defense of 3. Now, again, for anybody who's not familiar with Dungeons and Dragons, or anyone who is familiar, I'm going to oversimplify it massively. Essentially, I'm going to use my attack value, and we're going to take away their defense value. So we'll assume that I hit at maximum strength, and we'll assume that they defend with all of their possible power, and whatever's left over after that is the damage that I've done, and I'll subtract that away from their health. And it's a turn base, so if I do that to them, they get a chance to do it to me. So they'll attack with all of their strength. I'll defend with all of my defense there. And if the number is, if there's anything left over, in other words, if there's any power left over after my defense, which there won't be in this scenario here, there will be done this way, well, then I'll subtract that away from my health. And we keep going until somebody's dead. So what we do here is, if I want to say, let's say, me attacking Goblin, well, then what I would say is, there's a couple of ways I can do this. I can create new variables to hold my values. I don't necessarily need to do that. So I could say if P1.getAttack is greater than P2.getDefense. Okay, so that's the first thing I want to check. If my attack power is bigger than their defense power, well, then I'm going to say a couple things. First, I'm going to say direct hit or something like that, just to say, well done, you've hit the other opponent. And what I'm going to do is I'm going to work out what the damage is. So I'm going to say int damage is equal to P1.attack minus P2.getDefense. Okay, so that's going to go off to P1 and get the attack value, which is this one here, 10. I'll put 10 in there. It'll go off to P2 and get the defense value, which is this one here, 3. It'll subtract 3 away from 10, and it'll be left with 7. So the amount of damage that I do when I attack is 7. Does that make sense? So what I want to do is I want to update the goblin's health. So I could do P2.set set health. Now, I could do that, but that would cause an issue. Can anyone think of the issue that might cause? So when I first create my goblin, it's got 45 health. I check to see is my attack greater than my defense, than their defense. Yes, it is. I subtract their defense away from my attack. 3 subtract away from 10 leaves me 7. And then I set the health equal to 7. So the problem in that scenario is I haven't done 7 damage. I've actually done 38 damage because their health has gone from 45 down to 7. So that I don't want that. So I need to get their current health and then subtract that away, subtract the damage away from the current health and set that new value as a as what it should be. So there's a couple of ways I can do this. I can again create a new integer here, int current health is equal to p2.get health. Okay, so that will get their current value of their health. And then what I can say is that their set health is going to be equal to their current health minus the damage. Now, what that'll end up doing is it'll take 45 and subtract 7 away from it and leave it 38 and leave them 38 as a result. Okay, so that's all what happens if I am successful. If I attack the goblin and my power is better than their defense. I print out, yes, well done, you've hit them. I will calculate the damage, I'll get their current health, I will update their health to have taken that damage into consideration. The other scenario here is my attack wasn't stronger. So here I'm going to write you were not strong enough. And that's all I need to do. Just inform the player, hey, by the way, you attacked them, it didn't do anything. And because these type of games are, and actually, you know what, I'll leave you, I'll take this off a single line just so you can see the indentation on it. Because these games are turn-based, that's one turn for me. And now when you do it the other way around, the goblin attacking me. And essentially, I'm taking the exact same code, and wherever I have P1, I'm replacing it with P2. And wherever I have P2, I'm replacing it with P1.
I think we change the bottom one twice. B2 says that.
No.
The one below there.
This one here?
Yeah.
No, that's correct. Because remember, I'm player 1. So so this is basically I've been attacked, so I need to do it now. Okay, so let's go and have a look again at this. I have my class over here. Let's go back to home. Right. Okay, so I have my class, public side void main. I create my 2 objects here with my input values into it, and these are just elaborate excuses to go and call each of those methods. If we have objects where it says, "Oh, get me that value, return me that value," it's very dry. It's kind of formulaic. The interesting part is, again, the abstraction away from the problem. If I tell you, create an object that has a string data type, create a method to allow me to access that string data type called get and set, create a test program to get the current value of that string, change the value, and then get it again. 2 problems with that. 1, I've taken all of the problem-solving element out of that program. Okay, and hopefully, as you've seen from submitting zombie dice, I focus far more on how you could approach a problem than what exactly you're doing in the code. I want to see how you're taking the more abstract problem and making it specific into a Java implementation. So going through this allows me to show you how we're just treating this as variables, because all I'm doing here is get the integer there, so that will return back a number. Get the integer here, that will return back a number. Is the number on the left bigger than the number on the right? If it is, run this code. And this code just means get this number, subtract them away. That's the new value in this variable here. Get this number, put it in this variable. Subtract this number from this number, and set it to this variable here. And then the goblin's go the other way around. So if I ran this, and actually the running in this is, it's great because it's all in one system, but on a screen this big, it doesn't work as well. So let me zoom out. If I run F5 here, it's going to give me a terminal. No, it's not. Why would you? There we are. Okay. Okay, so here's the output from it. The first one is direct hit, and the next one is you are strong enough to defend yourself. So the direct hit is coming from up here, and me attacking the goblin, so I'm getting direct hit there. And then the you're strong enough to defend yourself is down here because the goblin is not strong enough to attack me based on the values we put in here. Okay. That okay with everybody? That makes enough sense? There are two problems with this code that we have now to make it a little more interesting. The first problem is we've each hit each other once, and that's all we've done. So the next task I'm going to set you to do is to make this turn-based, to keep going until one of us has a health of 0 or less. Okay, so that's the first issue, because you assume in any of these type of games, if you start a battle with a goblin, you're going to keep going until either you or the goblin are defeated. The second issue we have, if you look at an example like this, I will always defeat the goblin, even though the goblin has far more health than I do, and the goblin will never be able to attack me, because every time we do this calculation, get health and get defense, we're assuming that I'm hitting with maximum power and they're defending with their maximum amount of power, maximum amount of will, which is not how these games generally run. In most of these games, you will have a max attack power, and you roll the dice to see, well, how much of that are you using? So you might have a max of, let's say, 12, make it nice and simple. So you take 2 6-sided dice and you roll them, and whatever that number is, that's what you have. So you'll roll somewhere between 2 and 12. And that's how much attack you'll do, and they'll do the same for their defense. So what I would like you to add in is I'd like you to add in 2 elements, and I'll put this up as a reply on the Moodle form. The first one is make this turn-based, so we keep going until either you or the goblin has been defeated. And the second thing is I want you to introduce random numbers, where the values that I have stored here are considered to be the maximum attack or defense. And for any one turn, you will generate a number between 1 and whatever this value is here. So you'll go for a random number where this is the maximum you're aiming for. Does that make sense? So I'll put it up onto Moodle now. And again, we'll take about another 20 minutes to have a look at it. There. Okay. So, like that. And I'll put up that code as well. Okay. So that's going up on the Moodle form as well. The numbers are different in this. I have far more health here, but it's essentially the exact same way of doing it. You're not even a lot of document. basically is we have different height regions. So for me, it could be somewhere between 1 and 10, and my tactical for the dollar would be somewhere between 1 and 5.
Yes, but so not trying to remind you of that degree.
Yeah, so I've used the edge method to pull that up.
Yeah.
Yes.
On the exam, you can give that kind of exercise. We don't have time to do it.
No. I would give smaller. I would give it on the exam. The question is much closer to the size that you would have in the class test.
In class of the exam would be good.
No. But in the big exam, the class test, the questions you've got in the class test are roughly the same size as what you get in the examination.
Oh,
Okay?
So you're like, you know, that's nice.
Yes, I do. It is going to be.
You didn't put the correction for the test class yet.
I did.
You did?
Yeah.
Oh, sorry.
It's in the grade.
It's a-
Don't worry about that. Okay, so we are here. Next week we'll look at text files. The week after that, we'll look at binary files, and you'll get your third assignment. And it's the week after that, week 10. So that would be, if this is week 7, to count it forward time. This is week 7, week 8, week 9, week 10. So the 9th of April. Is that right? Assignment week, text files, binary files. Yes. The 9th of April. If I'm all wrong. Okay? I will double check that, and I will put it up on the forum later on this evening. Okay, another minute or two, and then we'll have a look at.
And can we use that program at home? The Visual Studio Code?
Oh yeah, yeah, yeah.
Doesn't have to be Notepad++.
No. I went with Notepad++, because again it's nice and bare bones. So when I would want you to remember that it's dot length or whatever, that's great. You can see now that there's definitely, like, if I create string s is equal to something or other, that I can. It gives you kind of predictive response, so I can have s dot, and it gives me a list of all the stuff that I can have in there. In the first semester, I tried to avoid that because you can see how much stuff is in here. It's overwhelming, and a lot of students will suspect, rather than going, I'm only restricting myself to character at and index of, they'll start scanning up the net, and it's kind of almost like, what do they call it? Indecision paralysis? Analysis paralysis, that's it. That they're kind of going, should I use this or this? Whereas if they only have a subset, they don't have a choice, so they have to get on and solve the problem. But yeah, no, absolutely. It's free, it runs on everything. It runs on Mac and Linux and Windows. Yeah, absolutely. I think I have... The only thing I found with it is with Java, you cannot do user input. You can't do input from the keyboard with Visual Studio Code. So you can write all the stuff in Visual Studio Code, but you still would have to hop out to the command prompt to actually run it. It's the one thing I haven't been able to figure out. I'm sure there's something I'm missing, but that's the one thing I haven't been able to work out. Okay, just gonna add in some stuff here since I know I'm going to need it. Add in, no, what is that? Okay. Okay, so I set you 2 tasks. The first one was keep battling until one of the health values is equal to or less than 0. And then the second part is the random number. So let's deal with the loop to begin with first of all. So what I'm going to do here is I'm going to have a very simple while loop, because it makes sense to me, because I don't know in any one of these attacks, when we have it fully working, it could be a case that both characters get damage dealt to them, only one character gets damage dealt to them, or no characters get damage dealt. So a for loop won't really work properly for me there. So a while loop is much better. So what I'm going to say here is while p1.getHealth is greater than 0. So if it's 0 or less than 0, it shouldn't do it. So as long as that health is over, and while p2.getHealth is greater than 0. So as long as both of those are true, the attack will the code will keep going round and round and round. Now, there's some nuances to this, so let me just so the loop that I've written here, just to say, while both their health is greater than 0, do it. It'll run me attacking the goblin attacking me, around and around and around and around. A couple of issues with that. First issue. What if I kill the goblin? Does the undead goblin get to attack me? Or does it finish at that point? So I probably should have one way of... To the first iteration, I'm just going to have a loop. But the second iteration, I'm probably going to have a look and say, well, if I defeat the goblin before they get to have their turn, we probably shouldn't bother evaluating their turn. That's a waste of resources. So we probably should finish at this point here. So we might have a little if statement here just to make sure that if the set health is less than 0, or sorry, get health is less than 0, break. It'll just quit that loop for us. But let's test that. And actually just for ease of viewing, because on a big screen this isn't the best to have a look at. So let's see the work. Java C, or test game. Okay, and then Java test game. Okay, so you can see here, I hit the goblin. I was strong enough to defend from the goblin. I hit the goblin, I was strong enough to defend. So it's subtracting 7 each time, and as it works its way down, it'll keep going until it gets to a point where we're less than 0. That's good, but I don't really know what's happening here. So I need to add in a little bit of extra context. So the first context I'm going to put in here is I'm going to let the player know it's there a go. So player's turn. And then once I know that, I'm also going to say Goblin's turn. So immediately that will speed things up or make things a little more clear because I'll be able to see who's doing what. What I might also do is, if I do some damage there, I might also want to say you have dealt okay, so you've dealt a certain amount of damage. And then obviously if the goblin happens to do something, we're going to say here, you have been attacked with how much damage dealt. Okay. So if I go back, I recompile. There. Okay. So now you can see player's turn, direct hit. I've dealt 7 damage. Goblin's turn. You were strong enough to defend yourself. Player's turn, and because we're not changing the values, there's never a different outcome. I can see people wincing when it flicks from the dark to the light. So hang on a second. Colors. Screen background. What if I do that? How's that look? Let's make the text a little more offensive so it stands out. Colors. Screen text. Oh. There. Okay, right. That's easy enough to read, is it? Okay, so it's not as bad flicking from one to the other now. I can see people go, "Whoa," and it goes from light to dark. Okay, so that's the first one. Now, this is good, but the problem is that what's possible to happen is that when it is my go, I will, so for example, if we go back here, if you've got 45, you take away 7, you've got 38, you take away 7, you've got 31, you take away 7, you've got 24. Have you? Yes, you have. You take away 7 for 24, you're left with 17, take away 7, you're left with 10, take away 7, you're left with 3. Take away 7, you're left with -4. But if you look at the last thing that happens here, the goblin gets one more go. So the goblin who is already dead, who's in negative health, gets to attack you one more time. So what we need to do is we need to declare before the goblin gets a go is if P2 dot get health is less than or equal to 0, you have defeated the goblin. And we'll break the loop there. Okay, that makes sense. So if we get to a point where we've dealt enough damage that we've reduced that value down below 0, we're going to say, all right, you've defeated the goblin, and we're actually going to stop the loops. The goblin won't have its last turn. And to keep things balanced, I'm going to take that if statement, I'm going to put it down here as well. I'll put all this code up on the OneDrive, so don't worry too much about frantically taking it down. So if my health is below 0, you have been defeated by the goblin. Okay, so we have both contingencies here. The goblin can defeat me, I can defeat the goblin. Save that, go back here, recompile, and run. Okay, so you can see that I have defeated the goblin. And again, I knew that was going to be the outcome because we never changed our values. And that's what we're going to do now. So I have my loop here. That will give me attacking the goblin and the goblin attacking me. But the problem here, as I mentioned previously, is the values that I have up here, 10, 6, 5, and 3, they never change. So I will always be a more powerful attack than what the goblin can do defense. And the goblin's most powerful attack will always be less than what my maximum defense is. So to make this more interesting, whenever I go to get their attack, I'm going to randomly choose a number between 1 and this number, and their defense will be randomly between 1 and this number as well. So to give the possibility that I won't always attack with maximum strength, and the goblin won't always be able to defend with maximum strength as well. And it means that it's not always going to be me that wins, it's not always going to be the goblin that wins. It allows for a little bit of variability. So what I'm going to do inside my loop is, well, outside here I'm going to create int p health, nope, p attack, let's put that there, int p1 defense. And then I can take these two and I can duplicate them. No, where have I done that for? P1 there. And now I can make this P2, P2, and I can introduce my random number. Okay, so every time I start my loop, so when I go one round over, I'm going to say P1 attack is equal to or dot next int, and I'm going to say here my maximum attack, so it'll be P1 dot get attack. +1. For the moment, we'll leave it as +1 so that the minimum, I would always do a minimum of 1, and they'll always have a minimum of 1 defense. Ideally, we should have the possibility of 0 there as well. So then we'll have P2 attack, which is for P2 get attack, and then for P1 defense. Defense and D.
So you're going to say +1 again.
Because the way random works is it'll generate a number between 0 and whatever's inside the brackets, which will mean it's a possibility of, it's between 0 and what's up to, but not including what's in the brackets. So it'll go, if I have 10, it'll go 0, 9. So I want 1 to 10. So that's where I'm getting that from. So the +1 is basically just shifting this window from 0 to 9 up to 1 to 10, 0 to 5 up to 1 to 6. Okay? Does that make sense? So these 4 values I've generated here, they're going to change every time we go around. So I attack, goblin attacks, we generate new values. I attack, goblin attacks, we generate new values. And now what I need to do is where I've got the get attack and get defense, I need to replace them with these the appropriate values here to represent my random numbers that I've used. So here I will call this P1 attack, and that's not a method. P2 defense. It's also not a method. Damage is going to be P1 attack minus P2 defense. That's okay. That's okay. That's okay. Right. So that's the first one done there. So you can see what I've changed is this no longer says get attack and this no longer says get defense because I've done this up here and got a random value around it. The get health and set health can remain the same because I'm dealing with specific values there. I'm not going to also, I've done 7 damage. Let's see what the random number is that we're going to take away from your health. It'll always be taking 7 damage or whatever the value is. And the same is going to happen here. So this is going to become attack, defense, P2 attack, P1 defense. Okay. So now what I've done, by using a little bit of random numbers here in these variables, I've made this game much more interesting. Because beforehand, it was a numbers game. You do 1 round of the calculation, and then it's okay. I know who's going to win this because whoever won the first contact is going to win every contact after that because the values are never going to change. Whereas now, it is possible that I will generate an attack of 1, and they'll generate an attack of 3 or 4, and my defense might be 1, and their defense could be 2, and they'll do damage to me, or it might be damage back to them, and so it'll change every time we actually do this calculation. So now, if I save this, screen. Okay. So much bigger value there. So it starts off with player's turn. I hit them. I've done 4 damage, which means that their defense was. It's changed from 7 last time. The goblins hit me with 2 damage. The player, I wasn't strong enough. That means that their defense was larger than whatever my attack value was. Goblin's turn. I was strong enough to defend myself. I did 4 damage. The goblin tried to attack me, but I was strong enough. Player's turn. I did 5 damage. The goblin did 1 damage. I did 2 damage. Goblin did nothing. I did 3. The goblin did nothing. I did no attack. I was strong enough to defend. I did no attack. The goblin did 2. So you can see that the health is dropping on either side as we're going down. But you can imagine I haven't actually displayed the health, which I probably should have as we were going through. And so it keeps going down. Lots and lots of turns here. Look, I've done 6 damage there. So that was quite a large attack. And I've defeated the goblin, okay? So I got to defeat the goblin. The goblin didn't get to attack me after he had died. If we try it one more time. I've defeated the goblin there as well. I imagine if I leveled those a little more, if I either gave the goblin more health or better defense or better attack, we would see that there'd be scenarios. I've only run 2 there. If I ran 20, there'd probably be scenarios the goblin won. If I ran 300, there'd probably be even more scenarios where we do that. Okay, so what we've done in today's class is we've taken the idea of an object, and our object is pretty basic. It's a way of holding 4 variables, a way of setting up their initial starting values, and a way of getting their values or updating their value if needs be. And we've taken that container and we've then built a little program around it, utilizing that custom data structure we needed for our program. If I didn't have this, I would need to have 4 variables per encounter. So I need to have 4 variables for my player and 4 variables for one enemy. And if I had 100 enemies, that's it. The next extension of this is that I'd create an array of goblins. And I'd go, see, could I defeat all of them? And as I'd work my way through, I would then have to have 4 arrays. 1 for the names of all the goblins, 1 for the health of all the goblins, 1 for the attack, and 1 for the defense. And that's kind of quite awkward. Whereas now I've got 1 class, which has all of my information held inside it. I still probably need an array to hold a group of goblins together. But it allows me to write neater code, to write more interesting code. And because the goblin or player is just dictated by their name, I could have different characters. I could have a goblin, I could have an orc, I could have a other mythical creature in there, and then I could randomly populate my array. I could have an array of 20. I don't know what monster is going to be in each of those slots. I don't know what health or damage or defense they're going to be able to do, but I could randomly generate that, and then I could create a game where I could have a certain amount of enemies in front of me, and I can defeat them one after the other, and then I get to a checkpoint. Do you want to continue, or do you want to run away with whatever goal you've got so far? And so you could keep expanding this model using a very, very simple object to represent every character inside your game, because all the game is battle. There's no narrative, there's no anything else. And we could work our way through. We could expand it, and we could have the player object, which has maybe an inventory or a backpack, so that they could hold things like healing potions. So their health doesn't automatically restore from one encounter to the next encounter. So from the first goblin, they might do 20 points of damage to my 100, and I could use a health potion to bring me back up by 10 points, and then I should see if I can continue on with my battles. It's a very, very simple game. There's no dungeon in it. If you had a one-dimensional array, it is a straight line dungeon. It's just how brave are you to go all the way to the end, or do you run away halfway through, or do you get defeated halfway through? We can make it into a 2-dimensional array, where we could have every cell representing a room, and in that room you would have a random number of enemies, and you could decide what orientation you wanted to go. Whether you want to go up, down, left, or right, and then we could navigate through the array looking for the treasure. When you get to second year and you start looking at algorithms like flood fill, you could have a 2-dimensional array that has rooms, but not every cell is a room. Not every cell has doors into every other cell. So you could build kind of a maze where you'd actually have to navigate your way through it. But they all start from the idea of having a really simple class structure there, or object structure there, and utilizing that custom data type. Does that make sense? Anyone have any questions?
If you upload the class,
I'll upload all the code I've done tonight, yeah. No worries. Okay, if you have no questions, that's us for tonight. Thank you very much. Next week we'll be back to normal